Alright, so here's where we left off on our image. Let's go ahead and just drag this to the side as a copy of it, and let's go back to before we applied all of our luminosities. So here is what the image was before, and here is what the image is afterwards. Um, just for comparison sake, 1 to 4. Um, not much of a difference in the sense here. You could have stopped here and done a little bit more saturation. Usually when I use all these masks, it creates a lot of softness to the image. So I like to do this luminance step to kind of restore all that sharpness to it. But like I said again, I mean, if you're happy with the way it looks there, then by all means, you can stop there. Um, but yeah, this is just comparing the two images there. One more thing that you can do here is if you have some some dark structures, you can go ahead and hit this script, which is a dark structure enhance script, which kind of darkens some of the dust lanes for you without altering the image too much. So let's see what this does. Alright, so you're probably going to look at some of these darker structures and see that they will line up when I reverse this. And when I redo it, some of the dust lanes go ahead and darken up there. So again, a lot of times you kind of just have to choose a stopping point with what the data gives you. Uh, Again, on each narrowband channel, not particularly a very bright target. This you might need 6 hours on each filter. Try to shoot for 20-minute subs. Those are going to be usually what I find the best 20-minute subs, and just six hours per filter, which is anywhere from 15 to 21 21 shots there. If you have a real bright target, 4 hours may do just fine, but fainter nebula, maybe the fishtail part of the heart here, you can do the 4 hours. But in this one, you might want to spend a little bit more time. The more data you have and the cleaner the image is, the less time and less noise you'll to kind of generate a nice image. And particularly the more time you spend, this is where a lot of your noise, because again the HA image is going to provide very good signal to noise ratio. Your other images, this is where all the grain noise in. And you'll find that you do 2 hours, you don't see much. If you were to add 2 more hours or even 4 more hours to this, it really starts to come together, and it also is going to do a lot more for your color separation between the colors in the image. You'll find that when you hit histogram transformation, you'll get a lot more distortion rather than maybe more green tones. Some images are tough where you just, that's all you get. It's green, so it's harder targets to work with. But let's go ahead and save it as, and I'm gonna just save it as a JPEG and put heart SHO so that you can look at it on your screen. And we're gonna put it at 100, and I'm gonna embed the ICC profile of my monitor to hopefully preserve what it looks like on my end there. So let's look at PixInsight there. Hard to say. So here's here's the image that we kind of worked on there. Again, not a bad image, but I think you would agree that that it is definitely a great improvement between what you have as an image, which this is kind of overdone, and not a lot of these structures are preserved versus what we have here. Again, it's not as high contrast, and maybe you can do a little bit more contrast on this image, but I tried to just kind of work with what the data gives me there. If for any reason this is maybe a little bit too bright, this is the SHO clone. You may want to bring this back down. Yeah, probably in between these first two bars is usually where I like to keep my images. So let's go ahead and save that there. And that's actually where I'll leave it. So let's save that again. Hard SHO, and I'm just gonna override that. Yep. Alright, so you'll see it here. This is your image, and actually, I've done a 4-panel or 5-panel mosaic of this same area with my RC8, which is, you're gonna get a little bit better, higher resolution with it, because this is exactly like 4 or 5 of your images zoomed in, put together. So of course you get a higher resolution in a sense, rather than if you're just shooting it with a wider field scope. It's not gonna have as much resolution. So if we go and kind of take a look at that, you can see the scale of things. So this is what my camera grabs with the scope that I have in one shot. And so obviously you got a bigger, in a sense, a longer focal length. You're going to capture a great deal of detail and higher resolution, and then when in turn you go ahead and put this in a mosaic sense, it's going to look real sharp to you. So you can afford to put images together and make a great image, but this takes a lot of time and a lot of nights, and you have to have a lot of patience. So once you get your rooftop going, this may be a lot easier. I know you said that you know how to make a rooftop, or wouldn't know how to do something like that, but none of us are builders or anything like that. I mean, if you have a common sense as far as doing astrophotography and working with equipment, I think you could be pretty smart enough to figure things out on how to make one. So if you need ideas, definitely 13,000 pounds. That's pretty steep there. I have my observatory, which I built, and you can kind of take a look there, and I mean it's pretty much step by step from when I dug the hole in the ground for my pier footer to actually, setting up the rebar structure for underneath, uh, filling in the actual cement on there, and put in the pier up, um, all the way to, this is actually my scope here with just the on the pier with just the platform there, um, but just framing everything, um, and then going ahead and actually putting some of the plywood on there. Uh, it had rained and things had warped, so I had to take these pieces of plywood off again and redo them. But essentially, it's not very difficult. Mine is not fancy or automated. I go in here, I have to push this rooftop off to get it to roll off. But take a glance at this. You may find yourself double thinking that this is almost impossible to do when actually it's not too bad or not too crazy. As far as making this observatory, um, you just have to have a design here where you have the tracks set up with some railings to hold the tracks in, rooftop somewhere where this budges and stops and seals there, and actually the outer flaps over here go through the outside to close things up. And then I have, I'm not sure if you'll see it. Yeah, you'll see it here. Um, I have an angle iron that goes over so that that edge rolls over and whatever rains there drips off and does not go in. So, um, you know, definitely not very expensive to build, um, and you'd be surprised how much more imaging you get done when you can just leave your equipment all set up and not have to set up every night. So. Just kind of going back to your image there, like I said, I think this is, just a lot of improvement of what you've been able to get, even though you have, you provided the same data. So, try it out. You have things step by step. I know at some points I went silent and I'm trying to kind of figure out what I'm trying to do, or it's a matter of trial and error. Do it, undo it, see what it does to the image. But this image versus what I was able to get, this is more towards the style of processing that I tend to do, where there's not a lot of contrast, but the image is soft and clean. And again, we didn't use any noise reduction. The image is quite smooth. So if you combine some of the processing here that we did and maybe add more data, you can get even a nicer image, where you can afford to do even more processing to it. But let me know if you have questions. Like I said, I'm happy to help. All right.